Question 5 on 2-3.
Let's see. Oh, yeah, we talked a little bit about this. So the thing is, some of you guys are making some mistakes. You're leaving the units out when that's kind of like part of the most important thing about this section is the units. They focus a lot of attention on what the unit should be. And then this question says, all right. Oh, who just left? Oh, I lost somebody. It wasn't the guy talking to me. Who was talking to me? Did I lose you?
No, I left and I joined on another device.
Oh, okay. I forget. All right. On number 4, you're going to take a volume of the balls divided by the volume of the can, right? Jeff, there you go. And this is going to be in so it's going to be some number cubic centimeters, some number cubic centimeters. So what happens to these when you divide them?
They gone together.
They do what now? Sorry?
They cancel each other.
Yes, they cancel. So percentages pretty much always are going to come out unitless. There will be no units left. Right? Yeah.
Okay. Then I was on the right track then.
Okay. All right.
Awesome. Thank you for the clarification.
Sure. Anything else, guys? Anything else? Do you guys remember what's happening today?
The quiz.
There's a quiz today. What? 2-1 through 2-3, right? So 2-4 will not be on there, the conversion stuff.
And it's due tomorrow at 7?
Tomorrow, 7 p.m. That's right.
Cool. Thank you.
Come on. All right, number 7 in the same section. Same section? This one?
Yes, 7A.
Oh, all right. So here's the thing. So the first problem we do in this section, Jeff, are tennis balls, right? So we have tennis balls in a cylinder, right? That's the first problem we do. We have 3 tennis balls in a cylinder. Second problem we do is racquetball. So a smaller cylinder and a smaller set of balls, right? All right, this is a horrible picture, but your percentage for part E, I know you asked about 7, don't worry, I'm building up there. Your percentage for part E should be the same because the balls got smaller, but the can got smaller, equally smaller. So of course the percentage should come out to be the same thing. They're the same shapes inside of the same shape. So this percentage should be equal to the earlier percentage. Now, is number 7 involving all the same shapes?
No.
No, I've got this box, and if I look at this box from overhead, you'll see exactly why I expect this one to not be as effective as a cylinder, because the corners are going to make there be a lot more empty space. Right, so this is not an efficient way to package any kind of balls because of the corners. So you're using more material for your container than you need to. Does that make sense?
Yes.
Okay, so that's the part A is just, what do you think is going to happen with the empty space? It's going to have more empty space. So overall, you have a business for a few years, you're losing money that you shouldn't be losing, because you're spending more on box material than you should be. All right, see how math helps you out, kids? Open a business. If you know some math, you'll make more money. Capitalism. Anyway, sorry. All right. No, I'm not trying to indoctrinate you into capitalism. I actually disagree with it. But hey, it's the system we have. So let's work with it. Is that okay? Anything else from?
Yes, thank you.
Sure. Anything else? You guys okay with everything else? Yes.
Question number 6, please. Because I made a mistake at the top and everything rest will be wrong.
Yeah.
Yeah.
So one thing on number 6, a lot of people are giving me answers but not showing me anything. So when I say show work, I just mean show the formula with all the appropriate numbers in there. But I can't remember what happened. So the volume of a ball, 4/3 pi times 2.8 cubed. I think you were forgetting the cube things. Didn't you make a mistake on the earlier problems too? Or was that somebody else? I can't. Somebody was forgetting to
No,
do the
I
power.
got it, but
Okay.
I think something wrong else.
But you put this in your calculator and you just got the wrong number? Is that what happened?
I think so, because I put it the total 3.73, but I have a lot of numbers of 3333. That's why I put something at the top. I'm not sure if you want to put all the number in this
No,
case.
no, of course not. Of course not. So
Yeah.
I have to look at your work to see exactly what happened.
Mhm.
But yeah. So let me take a look here. I'll let you guys think if anybody else has a question. Let me see, this is section 2.3, right? Where are you? There you are. Oh. All right, what happened to you? Yeah, no, that's the problem. That's the problem. You're forgetting to cube so look at your number 6, you didn't cube 2.8. Isn't 2.8 inside the part that's being cubed?
No, I put the cubed at that outside.
Yeah, okay. So let me come back to this. So you made the same mistake that you made earlier. So when I write this formula down, so it's 4/3 pi times 2.8 cubed. What is being cubed?
2.8.
Yes, 2.8 centimeters. You cubed the centimeters, but you never cubed the 2.8.
Oh, yeah.
You wrote it on your paper correctly, but you didn't put it in the calculator correctly.
Yes.
Okay. That's the same thing that happened on the earlier problem. Okay. All right. Anything else, guys? Okay. Oh. 2.3 number 2. Oh, so again, all right. So is this a specific, what went wrong with mine? Let me see. Oh, what happened? Yeah. All right. So number 2 is asking you, all right, so let's look here. Number 2 says, find the volume of empty space. This formula is the volume of empty space. So number 2 should be the result of this whole formula. And you put that answer down in number 3. That's all. Okay. All right. Volume of empty space, not the volume of final space. Empty space. Okay. Sorry. I don't know if anybody got that reference. Anything else, guys, before we get back to where we left off? Okay. Has anyone gotten to try section 2.4 yet? Is that going on? Anybody? I don't think I saw too many turned in. Yes. Okay. So Yeah, you got to get in there so you can see what kind of questions you're going to have. Let me see. So that was all about conversions. And the whole grid thing helps out. You're not going to need the grid for every problem, right? So, for example, if I ask you guys how many inches are in 4 feet, do you need the grid? Can you guys tell me how many inches are in 4 feet?
You multiply 4 times 12.
Yeah. So I don't need the grid for something like that because we're very used to those units. It's just a one-stepper. I don't need the grid. But you see, there's several problems where you really want to put the grid down because you're like, I don't know what the hell to do with this number and that number. Okay. So what's up, Trisha? What are you stuck on? Four on 2-4? Yes. Okay. You got a lot happening behind you there. Let's see. Oh yeah, this is a good one. All right. A surgical patient needs to have her liquid intake carefully monitored. How many milliliters of fluid did she consume if she drank half a liter of water, a pint of milk, and 8 ounces of juice? They want to know how many milliliters of fluid total. So what do I have to do with each of these?
Convert each one and then add them up.
Yep.
Okay.
So if I were you, if you're able to, I would have this sucker printed out. Where are you? 192. This thing, this page, I would have it printed out, sitting next to me. Right? There's a conversion chart sitting next to me. No, Billy Joel, stop it. And then you can see where to go. I can't remember already. I forgot what it was. You got to convert. Well, liters to milliliters is just a King Henry thing, right?
What's that smell?
I don't know. I really hope that Zoom doesn't transmit smells. Is it smelly in my place? Spring break is already going. Oh yeah, I understand, Trish. Don't worry. I'm not trying to say anything bad. I was just saying, wow, you got a lot going on and I feel bad for you. All right. Okay, good. So if that question makes sense now, that's cool. Anything else, guys? Anything else before we, oh, okay, cool. So we left off, all right, let me stop doing that. I'm gonna make you all sick. What's going on? Sorry. Adding scientific notation and crazy algebra stuff. Was that a question or is that just a, what is that? Sabrina, was that a question, Sabrina? Or are you just saying, oh, do you have a specific thing you're looking at? Was there a question that talks about that somewhere? Are you working on a problem that deals with that, Sabrina? Prep skills 2-3. Okay, let's take a look. It wasn't. So you mean the prep skills, not this prep skills, right? The next one. I don't see any scientific notation, so maybe you mean this one. No, wait a minute. Or 2-2. All right, let's see. Woo-ha! All right, let's see. What's this one? Is that the, okay, maybe the one before this. Okay. Here. Oh shit. This one? This one here? Yes. All right. Any specific part? I mean, can you guys tell me these problems right here? What is the main idea behind, well, actually all of these, to be honest. What's the main idea behind all of these?
Doing PEMDAS.
PEMDAS. I like it. Now, as a student in this class and any math class, it's up to you to realize when you should not use a calculator. Should you use a calculator on this problem?
You could, but you don't have to. Probably shouldn't.
All right. There we go. That's the correct answer.
I'm
You
sorry.
should not. I should see work. How much work? 2 steps of work, right? So I want to see the correct order happening. And I can't do that if you just plug all this shit in the calculator and let the calculator figure it out. It's not good. But what about this problem?
We can use calculator.
Yeah, throw that damn thing in the calculator. I'm not going to make you multiply by 1.05 12 times by hand. I'm not that insane. And the same thing with part C. All right. Now, after I've said that, can you give me a specific question, Sabrina? Number 4? Okay. So let me know if you have any troubles putting this in the calculator. If you put it in the calculator exactly as it's written, it'll work. Calculator knows order of operations. Scientific calculator, TI calculator, they know order of operations. I like it. Okay. All right. Let's see. So nothing else has come in. Okay, so we finished the conversion section and we did some extra examples of conversions. So I've just got to wait until you guys get in there and bring me some questions about conversions. Let's see, was there anything weird left over here? No. Okay, so you just got to get in there and let me know if you have questions. The next section, let's kind of get a preview of the next section, look at the prep skills leading into it. So there's going to be some graphing apparently. Right, you got to locate stuff on a number line. Oh boy, pie charts are back. Pie charts are back in town. So let me ask you this. Can somebody tell me how many students got an F?
19%.
All right, and do you see how that doesn't answer the question, right?
Yeah, you need to figure out what 19% of 31 is.
Good, so there's a total of 31 students. So we would have to do 19% of 31. I like it. Do you guys think that they did okay on the test?
Not really.
Not really. I mean, there are 48 A's and B's, 48% A's and B's, right?
About
But-
six students got an F.
Okay, thank you. Yeah, that's not the greatest. Not the greatest, but that's all right. This is Calc 2. That gets really nifty. It's one of my favorite classes to teach and one of the students' least favorite classes to take. It's so freaky. Let me see. There's bar graphs that happen, so you just have to know how to read those. These are old things. Scatter plot. Remember good old scatter plots? Here, let's get this first question knocked out. Can anybody tell me how many students scored less than 80?
Three.
So here's the 80. It looks like there's 1, 2, 3. It doesn't look like that's right on the 80. So that's probably like a 79. Do you guys agree with me? So there's 3. If you said 2, I would sort of understand, but that's definitely below the 80 line. So there's 3 students that got less than an 80. Okay. So it's all about, so it looks like there's some graphical displays, how to read them, how to plot stuff, percentages. All right, so let's see what this next section is all about. So this section actually brings in inequalities. It brings in some problem solving. right? Some word problems. Oh, shnikey. So let's take a look. Now, all right, this is a long read. Unless you just focus on the bold, right? Students, when they're faced with a word problem, they start to take numbers and start to do stuff with them without just slowing down and making sure you understand what the problem is about. Yes, word problems can be confusing. But let's see what level of word problem we're working with. So understand the problem. Or actually read through the problem and understand just the physical nature of the problem. Devise a plan. This is the hard step. Because once you got your plan, which is really creating a formula for true word problem, then you solve your equation and then you check your answer. So if you tell me that you need -7 feet of fencing to do something, I'll be like, what kind of material gives you -7 feet? So you got to make sure your answer makes physical sense. All right. Well, let's see. Yeah, this is all boring. Let's see where we get some good stuff. Here we go. Now we're getting into it. So this is one of the hardest steps about word problems is the fact that you have to translate English into Mathish. So this whole little chart is all about how do these English sentences look in Mathish, right? Have you guys ever seen this symbol here? I might have used this before. The little squiggly equals, looks like somebody dropped an equal sign, got all bent. So that means approximately equal to. Not equal to, that kind of makes sense. An equal to sign with a slash through it. Okay. Oh crap. Where'd it go? There it is. All right. And then we got these inequalities. All right. Notice this. Here's a little something. So I noticed that a few people have some trouble with inequalities and which one's less and which one's greater. Which one of these symbols, this one or this one, looks like an L that fell over? The first one or the second one? Which one looks like an L that fell over?
The second one.
Oh, crap. What would happen if an L fell over a little bit? Doesn't it look like that? The second one looks like a backwards L fell over a little bit. So that's not right. I really want you guys with me. I don't know how much, if you have any trouble with inequality symbols, but in case you do, does what I just said make sense? Doesn't that symbol look like an L that fell over a little bit?
Yes.
So that's the less than, L for less than, right? And the other one is the greater than. Some of you guys might have heard about the alligator. I don't know. Have you guys heard about the alligator?
Yes. The alligator.
Yeah, alligator wants to eat, blah, 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 whatever works, right? Alligator hungry. It's going to eat, arr, 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 arr. So the bigger number goes over there because it's what the alligator's going, I want to eat down. That looks like a snake.
I always thought it was like a less than and like greater than on the on like a number line. The greater than is pointing towards the positive, the less than is pointing towards the negative.
I see. So on a number line, they do act like arrows in a way, but you got to be careful about which way you think about it. So anyway, that's getting a little ahead of us. It's getting a little ahead of us. Okay. All right. Let me clear all this away. So there's the English. There's how you translate it. All right. Let me see. Let's get some interesting stuff here. Blah, blah, blah. Come on. Give me something good. Here we go. So real quick, somebody, can you estimate the monthly cost of homeowner insurance in California?
About $80.
Say again, sorry.
About $80 per month.
About 80. All right.
It's above.
Above? Okay.
Yeah, it looks like it's like a little bit above.
So give me a good estimate.
Like 81.
81. I like it. Do you think your estimate might be too high or too low for any reason? What do you guys think? If we go with 81? Maybe that's kind of hard to say, right? If we said 80, then our
I think
estimate,
low.
huh?
I think it'd be too low.
Too low
80 versus
probably, right?
80.
Especially if we
Yeah.
said 80, it would be obviously too low.
I think 81 is just right.
81 it feels pretty good about this. It looks like it's just barely above there. Okay, I
Yeah.
like it. So there's some estimation happening. So the true cost, we can say for sure that it would be greater than or equal to 80, for example, right? Or to be honest, it would just be greater than 80. We could probably say pretty confidently that it's greater than or equal to 81. So it's definitely greater than 80. You guys agree with me? It's definitely bigger than 80. But maybe we could say it's at least 81. All right, maybe. So inequality symbols are often used when we're trying to estimate something. We can give a feel for if we think our estimate's too high or too low. Okay, so that's one place we could use inequality symbols. All right, let me clear this away. Nothing too crazy has happened yet. Oh, if you're going to move somewhere, would you prefer to overestimate your costs or underestimate your costs? What do you guys think?
Overestimate.
Definitely. Right. Every time I was putting together a budget, I would always look at how much I spent on groceries the previous month, and then I would raise that up, right? Just to be on the safe side. So yeah, you always want to be more conservative. Blah, 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 blah. Okay, let's see. Oh, here we go. So, I mean, do you notice there's very similar questions? They give a different way to look at data. Estimate the minimum wage in 2009. So this will be interesting. Where do you think 2009 and which dot is 2009?
The last dot at the very top.
Yeah, the last dot. Do you guys realize, I'm sure some of you guys realize this all too well, that is the last time the minimum wage was increased, right?
725.
Jeff had his first job right in here, and I remember when this happened. Woohoo! Look at that. We're way up there. So real quick, there was maybe a politician that said, when I was a kid, I only got paid $4 or whatever the hell it was. If you translate that into today's dollars, it's like 15, 16 bucks an hour. If you take the minimum wage, what it was back in here, and you raise it with inflation, it would be $24 an hour today. That's just what it would be if it kept up with inflation. So this is evil, maybe some would say. I don't know. Is Jeff having opinions? I'm sorry, I'll stop. Sorry?
What you're saying, it's not evil, but I mean, it's also not right.
Yeah, it's not, well, it's evil.
Capitalism. Whether you like it, it's not fun.
Yeah, every time we've ever raised the minimum wage, nothing bad happened. Only good things happened. It's crazy. Anyway, I'll stop. I'm sorry. See, I'm doing the evil thing. I'm the evil professor indoctrinating his college students. Whatever. I don't give a shit. Just think. All right. Oh, sorry. Did we get, so what did we say? It was about 7. Some of you guys know exactly what it is. I know. But what's it look like it is here?
A little over 7.
A little over $7. Yeah. So if we guessed 7, that would obviously be too low of an estimate, right? So you would say that it's greater than $7. What is it? Anybody know what it actually is?
I think it's 72.5 because I remember working my first job at a water park when I was in high school, and that was what they paid me, was 725. But that was like New Hampshire, which
No, that's it.
lower over there. It's lower over there because it's
Yeah.
a smaller state.
This is the federal minimum wage. And of course, every state can have a higher minimum wage than that, but they can't have a lower one. So this is the federal minimum wage. So 725 is what it is. My first job, I made $3.25 an hour, I think it was. Yeah, it was right here. So when it went up and then it went up, and I was like, oh, I'm rolling in the dough. Of course, gas cost $1.20 a gallon. So I mean, it's so funky. Anyway, sorry. I remember. Anyway, sorry. All right, enough of that. I want to get some neat stuff. All right, now can you write this as an inequality? Man, I need to get at least a 2.2 GPA. Can you write that as an inequality? I need to get at least a 2.2 GPA. So I want my GPA.
To be
What
greater
symbol
than-
would?
Yeah,
Sorry?
greater or equal to.
Greater or equal to. I like it. At least a 2.2 GPA. Double secret probation. I have no freaking idea what that is. I don't understand what the hell they're talking about. We could fit at most 12 people. I love at most. We could fit at most 12 people. So let's use the letter P for people. What symbol am I going to put in the middle? At most 12.
Less than.
Good. People have trouble with at most and at least. If it said at most 12 people are allowed and that 13th person wants to come on, you're going to go, no, this thing is not going to break down because of you. Get out of here. Of course, nowadays, I would only take like 2 or 3 other people and make sure they're away from me, right? With the mask on and no Karens in the elevator, please. Thank you. Okay. I apologize for continuing the usage of the word of the name Karen in such a derogatory way. There's no Karens in here right now, but I feel bad for all the people named Karen. Whatever. Oh, who's got to chat at me? It's so funny. Okay. This is true. It's sad and funny and crazy. There are at least 50 ways. So guys, don't say anything out loud. Write a statement similar to the one I did. I had to pick a variable for myself. So you guys pick a variable and write an expression. Oh, see, I know a couple Karens who are very nice people. Yeah, it kind of sucks. I agree. So go ahead and write a similar expression for number 20. You got to pick your own variable. All right, so can somebody tell me what variable are you using? Oh, I like it. Somebody used LL, but unfortunately you didn't write the correct, let me look at you again. Yeah, you didn't write the correct, what's at least? No, equals would be equal. I want at least 50 ways.
Greater than.
Yeah, greater than or equal to. So the way I look at most is if I can have at most so many people on an elevator, I don't want more than that, right? So at most means up to. At most means up to. So at most 12 means up to 12. So less than or equal to. Does that make sense? At most means up to. Oh. And at least means starting at. So at most means up to, and at least means starting at, right? Starting at 50. So greater than or equal to 50, 50, 51, 52, 53. Does that make any sense? I mean, people have trouble with these at most, at least. Okay. So I get a text. I'm sorry. Go ahead.
You just said that it would be greater than or equal to 50.
That's
Wouldn't
right.
you be starting at the bottom?
Say again. Sorry.
Wouldn't you be starting at the bottom?
What do you mean starting at the bottom? What do you mean?
Because it says that there's at least 50 ways. So wouldn't
Yes.
that mean that it starts at 1?
No. Come on. All right. Think about this. You have to be at least 44 inches tall to ride the ride.
So 50 would be the minimum.
Yes, 50 is the minimum. So at least it tells you where to start, starting at 50. So greater than or equal to 50. You want 50, 51, 52? Is everybody with me? Okay. All right, because I know people have trouble with this, and I don't blame you, because you see the word least and you think less. You see this word most and you think more. But it's actually the opposite, because this tells you the maximum. This tells you the minimum. Okay, maybe. All right, maybe enough of those. I'm tired of those. Here we go. Ooh, this is neat. All right, these are neat. Has anyone ever seen anything like this? I mean, you all have, but you might not understand what it means.
I've seen it on like the weather stuff.
Sure. Anyone ever seen a topographical map?
Yes.
Yeah, so this could be like 500 feet, 400 feet, 300 feet. Okay. So that means if I'm standing here and my friend is standing there, we're standing at the exact same height above sea level, right? Anywhere along this line is 300 feet up. And then if I hike this way, now I'm 400 feet up. And if my friend hikes to here, he's also 400 feet up. Okay, I like it. So what does this line here mean?
-10.
Yeah, anything that's on this line is at -10 degrees. So what is the temperature doing between these two lines?
Increasing.
Increasing. I like it, from -10 to 0. So what's it say here? Estimate the temperature. Look at Las Vegas. That's going to be an easy one. Oh shoot! What did I just do? Okay. Look at Las Vegas. Right there. There's Las Vegas. This one's not even an estimation question. What's the temperature in Las Vegas?
40.
Yeah, you just got to follow. Woo-hoo, oh, 40. Okay, so 40 degrees in Las Vegas. What would be the estimate for Phoenix?
Probably like 47 or 48.
I like it. Sure. Right? It's closer to the 50 than it is to the 40 line. So I would say it's something closer to, oh, Jeff, get out of there with that. Closer to 50. So maybe 47, sure. Right? So there are multiple answers that make sense. If you said 42, that's obviously wrong, because it's further away from the 40 line. It's closer to the 50 line. All right. So this is not too bad. These get a little bit freakier. What about B? Why is B harder to estimate?
Because you don't have another line.
Yeah, I have no idea how far away the 60 line is. If it's this, then maybe it's 52. If the 60 line is here, then maybe it's 55. So that would be sort of an evil problem. The best I could say, what's the best I could say about B?
Greater than 50?
Good. I would say it's greater than 50. So what about M? M is also greater than 50. I just don't know how much, because I don't know where the next line is.
But we can see the repeat, that the difference is same from 0 to 10 to 20 to 30 to 40, 50.
Yes.
That's mean the another one was supposed to be 60.
Sure, but I don't know where it is.
Yeah.
Right? So again, let me show you. If it's right here, if that's where 60 is, then B would be about 55 degrees, right? But if the line is actually here, then I would, oh crap, this would be more like 52 degrees, right?
Yeah.
Because it's closer to 50 and further away from 60. So since I don't know where that next line is, that estimation is harder. I can't be as precise. Does that make sense? Okay. Maybe.
Yes.
All right. Oh, okay. We've done this kind of problem before. So we've looked at visual estimation. That's what we were just doing, was visual estimation. Now this is numerical estimation. Oh crap, what are you doing, Pen? If we borrow $10,000 at 7% interest for 3 years, would we want an overestimate or an underestimate as far as what our monthly payment's going to be? What do you think? If I want to figure out my monthly payment before I start, I get into a contract, would I want to overestimate what it's going to be or underestimate what it's going to be?
Overestimate.
Overestimate, exactly. You pretty much always want to overestimate your costs if you have to estimate one way or the other. I like it. Now, are we supposed to? Yeah, make your best guess. Okay. How would you make a guess at this if I wasn't letting you use a calculator, for example? What could you do to estimate this without a calculator?
You could make, do you make an inequality that states that it's greater than?
Well, the inequality is not going to help you get a number.
Okay.
I want us to get a number.
Is it simple enough to just find 7% of 10,000? What is that, 700?
Yeah, that's pretty simple, right?
Yeah.
But if the numbers were grosser, let me, yeah, this is not the greatest number. So, I mean, if this number had been 9,400 at 7%, right? This should have been the question because it's not really that hard otherwise, but I don't want to deal with this, do I? Stay with me, guys. Stay with me. Stay with me. So I would have to do 9,400 times 0.07 times 3, but I don't have a calculator. So what am I going to do? I would actually round this up to 10,000. That would make the end result higher than it's supposed to be, but that's what we want. We want an overestimation. So when I'm dealing with numbers and I want to estimate, I try to make my numbers round numbers, right? I try to make them rounder than they are. And which way do I go depends on, do you want an overestimate or an underestimate? Okay, maybe. Now I'm curious. I'm sure you guys are curious.
So
I want to
could
take a
you
look.
do the
Oh, sorry.
same thing with the percentage instead of
You
doing
could.
it at 7%, could you do it at 10?
Exactly. Now, what do you guys think? If we make this 7%, 10%, that is definitely an overestimate, but it's kind of a big overestimate. Do you guys agree? No?
Yeah, because that's a huge port. Like, you're really overestimating like almost 50% of what the
Yeah,
original
there you go.
percentage is.
Yeah, exactly. But it would still be an overestimate, right? And if that number comes out to something you can live with, then you know you can live with the 7% for damn sure, right? So, I mean, it's still legitimate to do that way. Okay. Of course, if I was in this case, I would freaking find a calculator because I'd probably like to know exactly what it's going to be, but still, you can estimate. Now, I want to jump ahead of this stuff. I want to take a look at what the homework looks like with you guys. And then we'll probably call it a day. Yeah, why not? I got to go to the dentist here this morning, so I might as well end class a little early and get mentally prepared. Okay, so they give you this situation, and do you notice what's missing?
The actual percentages.
Yes, so this is a visual estimation that you have to make. You guys with me? So, I mean, this looks like it's going to be almost half. All right. So just going to, and you got, there's 11 hours in this chart. So that's going to be an interesting thing for you guys. You got to estimate somehow what the parts of this are. Okay. Blah, blah. They investigate inequalities. Oh, and then this is really, all right, let's look at this problem. They didn't give enough of this in the build up to this. So if I'm going to go to the store, I'm going to buy this stuff. Let me see, do they give us an idea? No. how am I going to estimate my total cost? What would I do to estimate my total cost? So I got 4 boxes of mac and cheese for 89 cents a box.
So personally, I would round up to the nearest dollar.
Yeah, yeah. So you make this $1. So now you can figure out that would be $4 total, right? Because you got 4 boxes at $1. You'd round this up. You could round this up. You could round this up. And that definitely will be an overestimate. But again, you want to overestimate when it's money you're losing, right? All right, so that's how also number 4 works. I like it. So this is the true numerical estimation, where we just make the numbers round, right? Okay. So that's okay. Oh, it keeps going. Here's another visual estimation problem. Visual estimation. Okay, so not too bad. Not too bad. And then just to kind of look ahead a little bit, the next thing, or good old Albert, we're going to get into, how do I say this? This is going to be related to discounts and markups, relative change. All right, I don't want to get too deep into that right now. Okay, I think that's pretty good. That's how far I wanted to make it today. It's very early, and I don't really care. Hopefully you guys don't care too much that we're leaving early. But that's it. That's all I got for today. So let me know if you have any questions, if you want to hang out. The quiz will unlock at 10 a.m. So if you want to get started on it right at 10 a.m., you can. Otherwise, we're done. So let me know if you need to hang out, if you have any questions. Otherwise, you are free to go.
Have a great weekend, Professor.
You too, Tristan.
Okay.
See you
Bye.
later.
Thank you.
Okay, see you guys.
Thank you.
Sorry? Is everybody good? All right, I'm going to head out. See you guys.